Let us now prove that the function square root of x, which is defined from 0 infinity to 0 infinity, is continuous. Now how do we show this? Well, we resort to the epsilon delta definition. This can be done using sequences also, but as an illustration, let me do it via epsilon and delta. First consider the case x equal to 0. Well, square root of 0 is 0. So what we are asked to do is we have to somehow show that the epsilon delta definition is satisfied at the point 0. So fix epsilon greater than 0. We need to find delta greater than 0 such that if mod y minus 0 is less than delta, then mod square root of y minus square root of 0 is less than epsilon. So essentially we have to find a delta such that mod y less than delta implies square root of y less than epsilon. I can ignore the modulus here also. Okay. Now if delta is equal to epsilon squared, if I set delta equal to epsilon squared, then y is less than epsilon squared implies square root of y is less than epsilon. Okay. So the showing continuity at the point 0 turned out to be quite easy. Now fix some point x not equal to 0. Okay. Then we have to estimate modulus of square root of y minus square root of x. Okay. Now we use the oldest trick in the book. This is equal to square root of y minus square root of x times square root of y plus square root of x divided by square root of y plus square root of x. Right? I can divide and multiply by this. One reason for that is the denominator is not 0. Root y plus root x is not 0 here. Okay. Now what do we do? Well, we observe that this numerator is nothing but y minus x modulus by square root of y plus square root of x. Okay. All I have done is square root of y plus square root of x is positive. I have put a modulus and taken square root of y plus square root of x inside, multiplied and got mod y minus x by square root of y plus square root of x. Okay. Now this is certainly going to be less than mod y minus x by square root of x, because square root of y would again be a non-zero quantity, or it could be 0. It's a non-negative quantity. It's a non-negative quantity. So I am just getting rid of something that will make the denominator larger, so I can write this inequality. But root x is fixed, is a fixed quantity. It's a fixed quantity, right? So by the k epsilon principle, we are done. That was fairly easy. Please, as an exercise, show the same thing using sequences. This is a course on real analysis, and you have just watched a module on the function square root of x.